How do you subtract rational expressions? By finding the LCD. Imagine you're working with fractions, but instead of simple numbers, you're dealing with polynomials. Subtracting these can seem tricky at first, but it gets easier once you understand how to find the least common denominator. First, remember that a rational expression is just a fraction where both the top and bottom are polynomials. You can only subtract these expressions directly if they have the same denominator. If they don't, you need to find a common ground, which is where the least common denominator comes into play. Start by factoring each denominator completely into its prime polynomial factors. This step is super important because it shows you all the building blocks of each denominator. For example, if one denominator is x2, 9, you can factor it into x3, x plus 3. If another denominator is x2 plus 6x plus 9, you can factor it into x plus 3, 2. Next, find the least common denominator. This is the smallest expression that contains all the factors from each denominator using the highest power of each factor. So if one denominator has x3 and the other has x plus 3, 2, your LCD must include both x3 and x plus 3, 2. That means your LCD is x3, x plus 3, 2. Now rewrite each rational expression with the LCD as the new denominator. To do this, see what factors are missing from each denominator. For the first fraction, which has x3, x plus 3, you need to multiply numerator and denominator by x plus 3 to match the LCD. The second fraction already has the full LCD, so no changes are needed there. Once both fractions have the same denominator, you can subtract the numerators directly. Be sure to enclose the second numerator in parentheses before subtracting to keep the signs clear. For example, if the numerators are 4x plus 3 and 3x3, the subtraction becomes 4x plus 3 minus 3x3. Now perform the subtraction in the numerator. Distribute the numbers across the parentheses. For x plus 12, 3x plus 9. Combine like terms to get x plus 21. The final step is to write the new rational expression with the simplified numerator over the LCD. Check if you can factor or cancel any common factors from the numerator and denominator. In this case, the numerator is already simplified, and the denominator is x3, x plus 3, 2. Finally, remember to note any restrictions. These are the values of the variable that make the denominator 0, which are not allowed because division by 0 is undefined. For this example, the restrictions are x plus nec 3 and x plus nec. By following these steps, factoring denominators, finding the LCD, rewriting fractions, subtracting numerators, and simplifying, you can subtract rational expressions with confidence. It turns a complex task into a straightforward process, making algebra much more manageable.